in test 2 according to the course outline. You just have to refer to your course outline. And we've covered everything, so you should be okay. Make sure you have a scanning app so that you can take a picture of what you have written and then turn it into a PDF. Okay, it shouldn't be too difficult. Just make sure you're ready, and yeah, you'll be fine. Okay, so we continue with the binomial theorem, and like I said yesterday, there isn't much in this chapter. Once we've done the Pascal's triangle and the binomial theorem itself, that's pretty much what the chapter is about. So today we can just go over more examples. Remember, yesterday I said that if you have a binomial, this is what a binomial looks like. So you have a plus b to the power of n. So it is two terms. That's why it's called a binomial. Okay, and it's raised to the power of n. When n is a positive integer, then you can use Pascal's triangle. Pascal's triangle, we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So you just add there these two, these two, those two, give me 2, and then 1 and 0. So these two together give me that number, like that. So if I want to get this number here, it's 4. That one is 6. It's 4, and then a 1 at the end, and it forms like a triangle. And these numbers are the coefficients of your, this is 6. These numbers are the coefficients in the expansion. But the Pascal's triangle is not useful when we are dealing with exponents that are not positive integers. So we looked at an example yesterday where we had a plus b to the power of minus 2. So the first way we did it was by long division, and just getting two terms we had to do a lot of calculations. Okay, so you can use long division to expand this. And this works in the normal way. We do long division. Okay, and then the other way we did it was the binomial theorem itself. And you could see that we were able to get 4 terms, and it didn't take as much work as long division, right? Except that there are some restrictions. So when n is not an integer with your binomial theorem, the restriction is that the absolute value of b must be less than the absolute value of a. Remember what absolute value means. Absolute value just means the distance that a number is away from 0. So if I have absolute value of 5, this is equal to 5, because 5 is 5 units away from 0. Absolute value of minus 2, this is just equal to 2, because on the number line, minus 2 is 2 units away from 0. It's just on the left-hand side. So we continue with some more examples. Whenever you're given a binomial expansion, work it out, substituting into the formula, and then remember to add any restrictions if there are any. If your integer, your exponent is a positive integer, then there are no restrictions. If it is any other number, then you do have some restrictions. So we can start with a simple one. We have 2 plus 3x to the power of 3, and then we have to expand this using the binomial theorem. So remember how this goes. It is a to the power of your n, and then the powers of a decrease. And then b, which is this one, 3a, the whole of it is my b. Those powers increase starting from 0. And then the powers of a will keep coming down. And you're also dividing by factorial. You start from 0 factorial, 1 factorial, and so on. So you start with 2 to the power of 3. Okay, you can put this over 0 factorial, because 0 factorial is just equal to 1. And then we said the 3 will come down. So I have the 3 coming down. Then the powers of 2 decrease by 1. So I have a 2 over there. Then the power of b, which is 3x. At the first step over here, power of b was 0, so that's why I didn't write it. But you can write it so you don't forget it. Okay, so now it's power 1, and then I divide by 1 factorial. Then I continue. The 3 came down, now the 2 must come down. So the 3 was down there. So there's the 3, this 3 here. And then it comes down, it was already down. The 2 should also come down. And then the powers of 2 decrease by 1, that is my A. And the power of B increases by 1, so it becomes 2. 1 plus 1 is 2. And then I divide by 2 factorial. Okay, then I continue again. This time 1 will come down, so it's 3 times 2 times 1 times 2 to the power of 0, so I'm not going to write it, but I can. 2 to the power of 0 times 3 to the power, 3x to the power of 3 over 3 factorial. Okay, now you'll notice I can continue. It's possible because the binomial theorem doesn't really have a stop. You just go on. But if I were to continue, next it's the 0 that would come down. So the 0 would come down, and everything I multiply the 0 with will turn into 0. So I'll just have plus, I have plus 0, plus 0, plus 0, and so on. Because the numbers that I bring down, you can see the 3 that I brought down over there, they never disappear. They're always multiplying. So once I bring a 0 down, everything that comes after will still multiply with that 0. So that's why there's no need to write anything after that. Okay, so what we do is we just simplify what we have. So this is equal to, the first one, we just have 2 to the power of 3 divided by 0 factorial. That's 8 divided by 1, because 0 factorial is equal to 1. So this is 8. And then I have 3 times 2 squared. 3 times 2 squared, that's 12. 12 times 3 is 36, and I have 36. Okay, so I have 36. And the power of x is 1. Okay, and then I continue. I am now at this one over here. So I'll say 3 times 2 times 2 times 3 squared divided by 2 factorial. That one you do it on your calculator. You'll notice that the 2 factorial can cancel with one of the 2's, because 2 factorial is 2. Okay, and then you get 54. So this is 54. And this is x squared, because my x is being squared over there. And then the last term, now this part over here, 3 times 2 times 1, that is just 3 factorial. and this is also 3 factorial, so those two will cancel each other out. Then I'll be left with 2 to the power of 0, which is just 1, and then 3 to the power of 3, this is 27, and then I have x to the power of 3. Okay, so that is my expansion. You could also try this one with Pascal's triangle. You put your coefficients 1, 3, 3, 1, and then you say the powers of A are decreasing, the powers of B are increasing. You will see that you get exactly the same thing. And here there are no restrictions. Okay, the reason there are no restrictions is because my exponent over here, 3, is a positive integer. Okay, and the next one, 1 minus x to the power of minus 1. Okay, and we have to expand this. Now when your exponent is not an integer, is not a positive integer, they will tell you to how many terms you should give in the expansion, because it never stops. So we want everybody to give the same number of terms, and 4 is usually standard. Okay, so 3 or 4, and here we say 4 terms. Okay, so the procedure is the same. The first one is, you can say this, my A is 1, and then my B is minus A, minus x. Okay, and then you substitute them into the formula. So for the first one, A has to be raised to the power of minus 1, and B will be raised to the power of 0, so I don't need to write it. And then I will divide by 0 factorial. And then what will happen is the minus 1 will come down, and then the power of 1 will decrease by 1 to become minus 2. Okay, so I know all these values, 1 to the power of minus 1, 1 to the power of minus 2, these are all equal to 1. The reason I'm writing them is for the next step, to see what power comes down. Okay, so if I don't write it, at the next step I'll have to wonder what power must I now bring down. Okay, and then now B is minus x to the power of 1, and then this is divided by 1 factorial. And then I have minus 1, which was down there already, then times minus 2, and then I have 1 to the power of minus 3, and then minus x to the power of 2, divide this by 2 factorial. Then the last term that I have minus 1, minus 2, minus 3, and because this is my last term, I can just leave it as 1. So we're asked to find 4 terms, so it's 1, 2, 3, 4. So I can leave that on as 1, because the only reason I was writing these exponents is to know, okay, next it's the 3 that is going to come down over there. So this is just 1, and then I have minus x to the power of 3, then I divide this by 3 factorial. Okay, so that's just me substituting into the formula. I just put the dot 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 to show that it continues. Now this one will have restrictions. I'll write it after I'm done simplifying. So for the first one, the first term over here, negative 1 to the power of negative 1 divided by 0 factorial. We know that 1 to the power of anything is equal to 1, so my first term just becomes 1. Okay, then the second term, I have minus 1, and this term over here it's negative x to the power of 1. This is going to be negative. If I have negative times a negative, this will be positive. And 1 to the power of anything is 1. So I just have positive x. And then my third term over here. So this is negative 1 times negative 2. This is positive 2, because negative and negative. And you see that this positive 2 will cancel with 2 factorial, because 2 factorial is equal to 2. So I'll be left with 1 to the power of negative 3, which is just 1. And then this term over here, when I square it, it becomes positive. So what I have is just plus x to the power of 3. Okay, and then the third term, the fourth one, sorry, this negative, 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 it'll get a negative answer. But then negative x to the power of 3 is negative. So that means I actually have 1, 2, 3, 4 negatives, which makes a positive. Now this 3 times 2 times 1, that is what 3 factorial means. So this 3 times 2 times 1 in the numerator will cancel with this 3 factorial, and I'll just be left with 1 and x to the power of 3. X to the power of, sorry, this one was 2. And then x to the power of 3, and then I have dot, 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 like that. Okay, so this is my answer with 4 terms, and then my restriction. So this does have a restriction because my exponent is not a positive integer. So the restriction is always that absolute value of b should be less than the absolute value of a. So I have absolute value of minus x. This should be less than the absolute value of a, which is 1. And this is just absolute value of x is less than 1. Okay, because absolute value of 1 is 1, because 1 is 1 unit away from 0. And absolute value of minus x is equal to x, because x and minus x are the same distance away from 0. Like 2 and minus 2, they're the same distance away from 0. Okay, so you can just write it as minus as absolute value of x. And then 1 plus x over 2 to the power of half. So we do this one in pretty much the same way. Okay, so the powers of a will decrease, the powers of b will increase from 0, and we must have 4 terms in this expansion. Okay, so my first term is just 1 to the power of a half, and then I'm dividing by 0 factorial. So again, this 0 factorial, you don't need to write it, it's just that you don't forget to write it at the point when you start with 2 factorial, 3 factorial, and so on. Okay, that's the first term. Then the second term, the half will come down, so I have half, and my exponent of 1 will be negative a half, because it's half minus 1. So you always subtract 1 with the exponent of a. Okay, and then now b, this is x over 2. I hope you can see that. That's an x over 2. The power is 1, but I don't need to write it. And then I divide this by 1 factorial. Then the next term, This minus half will now have to come down. So I have half there already. Then minus half comes down. Then I have x over 2. The power increases by 1 to become 2. And then I divide by 2 factorial. Okay, I didn't write the 1, but so the power of 1 must be 3 over 2. Okay, so here, this 1, the power is minus a half. Then I have to subtract 1. So minus half minus 1 is minus 3 over 2. Okay, and again, the reason I'm writing it is so that I am clear on what power comes down. So next one, I have half negative half, and then negative 3 over 2, and then I have 1 to the power of negative 5 over 2, and then there's x over 2 to the power of 3, then I divide by 3 factorial. Okay, so that will be the last term that I write. So I put the dot 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 because we're asked to write this to 4 terms. We have 4 terms in the expansion. Now I simplify. Okay, so my first term is just 1. So this one over here, I have the 1 to the power of half. It's just 1 over 0 factorial. So I have 1 over 1. So this is just 1. And then the second one, I have half times x over 2. So that's like half x. So I will have x over 4. Because when I divide it by 1 factorial, it's just a quarter. So it's a half times the half x. That gives me a quarter. So okay, and then the third term, it's over here. I have half times a half, and then I will have a half squared, which is 1 over 4, and then I will divide it by 2 factorial. And this will be negative because I have only one negative sign over here. So it's half times half squared divided by 2. That's like multiplying by another half. So I have a 1 over 2 to the power of 5, and that is negative. So it's negative x squared. The x is squared. Let me just scroll up. You can see over here the power of x is squared, and that's where I got the half squared from. So this is x squared divided by 32, and it's negative. Then the last term, okay, so I have half times half times half. So first my negatives, I have 1, 2, so the final answer will be positive. Then I have half, 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 and half to the power of 3. That is already 2 to the power of 6 in the denominator. And then this 3 here in the numerator will cancel with that 3 with the factorial. Then I'll be left with times 2. Because remember, let me write that here. Remember that this is equal to 3 times 2 times 1. So this 3 here will cancel with that 3 over there. And then I will be left with 2. So I have 1, 2, 3, 4, 5, 6, 7 2's. Okay, so this is positive x to the power of 3 over 2 to the power of 7. I got 128. Okay, and then it continues in the same way. Okay, but you can just do that on your calculator. Type this in, this times that, and then you know that this is a half cubed, right? And then divide it by 3 factorial. You'll see that that is what you get. Now this must have restrictions. So the restriction is that the absolute value of b, in this case this is x over 2, this must be less than the absolute value of 1. So this is just absolute value of x over 2 is less than 1. Okay, and this is also equal to absolute value of x is less than 2. The reason is because absolute value of x over 2, you can write it as absolute value of x divided by absolute value of 2, and then absolute value of 2 is 2, and then you multiply the 2 on both sides. The sign doesn't change where it's facing because you're multiplying by a positive number on both sides. Okay, we have 1 minus x to the power of 5. We have to use the binomial theorem. These ones are the easiest ones. What we do is still the same. So the first one, I have 1 to the power of 5. I divide this by 0 factorial. And then I have 5 times 1 to the power of 4. And then my b, which is minus x to the power of 1, divide this by 1 factorial. And then I have 5 times 4 times 1 to the power of 3 minus x squared. Divide this by 2 factorial. And then 5 times 4 times 3 times 1 squared minus x to the power of 3. I have to divide this by 3 factorial. And then I have 5 times 4 times 3 times 2. Now I'm not going to write the 1. This is minus x to the power of 3. So the one that I didn't write in this case is 1 to the power of 1. Okay, so I didn't write that one. Then divide by 4 factorial. So I'm not writing it just to save space. And then I have 5 times 4 times 3 times 2. And then the last one that I'm not writing now is 1 to the power of 0. Okay, and then I have minus x to the power of 5 divided by 5 factorial. Okay, so that is me just applying the binomial theorem. Okay, so I start simplifying my terms. So the first term is just 1. You can see it over there. It's 1 to the power of 5 divided by 0 factorial, which is 1. Okay, then the second term, I have 5 times 1 divided by 1 times minus x, that is just minus x. so minus 5x. Then the third term, I have 5 times 4 times 1 divided by 2, that is just 10, and then minus x squared is x. So this one is positive, so I have plus 10x squared. Then the third term, I have 5 times 4 times 3 divided by 3 factorial, that is also 10, and this time it is negative because this term over here is negative, so it's negative 10. Then the last term, I have 5 times 4 times 3 times 2, so this over here, remember that is the definition of 5 factorial. You can write the 1, but multiplying by 1 doesn't change anything. So what I have over here, this is 5 factorial, and it's there in the denominator, so it'll cancel out. Then I will be left with negative. Did I skip one? I think I did. The fourth one, sorry. Okay, so here, the fourth one, the third one. Okay, I'm getting confused. The next one, it's 5 times 4 times 3 times 2, and then you see that this part over here, 4 times 3 times 2, that is equal to 4 factorial. Okay, so I will be left with 5. So I have plus 5x to the power of 4. So this is positive because my exponent is even. And then the last one is the one that is negative. Okay, and that is negative x to the power of 5. Okay, and again, there are no restrictions over here. Right, so I didn't continue because I didn't put the plus dot 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 because I said the term that I left out here was power of 0, and when the 0 comes down, everything after that is going to be 0. So it's different from the other expansions where what you get after that is not 0, but with this one, what you would get next is just 0, so there's no need to put the plus dot 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 after that. Let's do another one. We have 1 plus 2 to the power of x to the power of half. So this is the same as the square root of 1 plus 2x. So when you get that question, find the square root of 1 plus 2x. This is basically how you are going to do it. So I want to work out 4 terms in this expansion. So what I do, the first term is just 1, okay, and the second term, say the half will come down, and then I will have 2x. And then the next one, we will have half minus a half, so the power is coming down, and then I have 2x to the power of 2. Divide this by 2 factorial. So I hope you know how I'm getting these. Then the next one, I have half minus half minus 3 over 2, and then I have 2x to the power of 3 divided by 3 factorial, and this continues in this way because I will never have to bring a 0 down. Okay, then I simplify as far as possible. My first term is just equal to 1, so this is just equal to 1. Then let me write this better. So my first term is just equal to 1. Then the second one, you can see I have half times 2, that is just 1. I have plus x. Then the next term, I will have half times minus half, that's 1 over 4. And then this one over here, I get a 4. So I have negative a quarter times 4, that's just negative 1. And then I divide it by 2, so that's half. And this is negative x squared over 2. And then the last term, see half, half, half with a 3. There's 3 halves, and then there is 2 to the power of 3. All those halves will cancel with this 2 to the power of 3. And then this 3 over here will cancel with that 3 over there. And then I'll be left with 2 in the denominator. And this is positive because I have negative and negative. So my answer should be positive. This is positive x to the power of 3 over 2. And then you continue in that manner. Okay, then the restrictions. This is that absolute value of b should be less than absolute value of a. So that's absolute value of 2x is less than the absolute value of 1. So this is just absolute value of 2x is less than 1. And this is also the same as absolute value of x is less than a half, because when you're multiplying two absolute values, you can write it as the product of their absolute values. So absolute value of 2x is the same as absolute value of 2 times absolute value of x, and then you can divide by the absolute value of 2 on both sides. That's where I got that one. But even this is perfectly fine. Let's see. X minus 1 over x to the power of minus 1. And I want to work this out using the binomial theorem. Okay, so the procedure is exactly the same. It's a formula that I just have to substitute my values in. So for the first one, I will have x to the power of minus 1. I will divide this by 0 factorial, which is just 1, so I don't even need to write it. Then the next one, I have minus 1 and x to the power of minus 2. And then I have minus 1 over x to the power of 1. This is divided by 1 factorial, so I don't need to write it. Then the next term, I have negative 1 times negative 2, and then x to the power of negative 3 times negative 1 over x to the power of 2, and then I divide by 2 factorial. And the last term that I'm going to work out, this is negative 1 times negative 2 times negative 3 times x to the power of negative 4, negative 1 over x to the power of 3, and this is all over 3 factorial. And I have to put my dots to show that it continues in that way. Okay, then we simplify as far as possible and then write down our restriction. So the first one, I have x to the power of minus 1. So I'll write it like that. Simplify everything and then maybe rewrite it as 1 over x again. Then the next one will be a positive term as well, because this is negative, and then that is negative. So the product will be positive. So this is 1 over x squared. This is 1 over x, so I get 1 over x cubed. So maybe I should just do that. Let's rewrite this as 1 over x. Then the next one, we say that's 1 over x to the power of 3. And then the next one, I have negative, negative, that will be positive. So I have 2, so it's positive 2. And then I will be dividing that by 2 over here. So those cancel. And I will be left with 1 over x cubed times 1 over x squared. So that is just 1 over x to the power of 5, and it's positive 1 over x to the power of 5. And then the last one, negative, 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 and negative. So I have 4 negatives multiplying. My answer will be positive. Then I have 1 over x to the power of 4 times 1 over x to the power of 3. So I'll have 1 over x to the power of 7. Then this 3 times 2 times 1, that is the same as 3 factorial. So those two will cancel each other out. And then I'll be left with plus 1 over x to the power of 7. Then I have dot, dot, dot. And I'm sure even without writing the expansion over here, you can tell me what the next term will be, because you can see there's a pattern that the terms form. And the restriction is that absolute value of b, which is absolute value of negative 1 over x. This must be less than absolute value of x. So what we have is 1 over x will be less than absolute value of x. Okay, so that is how we would do that one. So with that, we are done with the binomial theorem. You can see it's not difficult, it's just remembering the formula. Okay, so if you remember the formula, then you're set. The rest is just to practice. There are lots of exercises in your book, so please go and try those ones. Okay, so the next topic is on differentiation. Okay. Now, before we talk about differentiation, we have to talk about functions. What is a function? A function is just a mapping from one set to another. So think about it like a machine where you put something in So you have a machine like this, and you put something in, and then the machine does something to it, and then you get an output. So you have an input, and then there is an output. So that's basically what a function does. You give it x, and then something comes out. So an example of a function, we have y is equal to x squared minus 2x plus 1. So here we say that y is a function of x because I will give y x. So if this is my function y, so my input will be x, and then what comes out will be x squared minus 2x plus machine. You can think of those assembly lines that we have at one station. This is what happens at the next station. This is what happens, and so on. So you just put in x, and then you see what comes out, and then that defines your function. Now in this case, when you have y is equal to x squared minus 2x plus 1, excuse me, we say that x is the independent variable, and then y is dependent. Okay, so the value of y depends on what x is. So that is why it is called the dependent variable. Okay, now there are several ways that we can write this. That is the notation. So we say that y is a function of x. So y is a function of x, and we say y is equal to f of x. So this is one way of writing it, that y is a function of x. Then we write y is equal to f of x. We can also write this y, we sometimes use capital F of x. You can say y is equal to y of x. So the letter doesn't actually matter. Or you can say I have a function f that takes x, and then what I get out is f of x. This you say is a mapping. Okay, so you take x and then you map it to f of x. Okay, so these are just the different ways of writing the same thing. So when you see this, don't think it's something different. It is actually the same thing. So this function f maps x onto f of x. That's what it means. Now when you're given a function, let's use the f of x that we have over here. So f of x is squared minus 2x plus 1. I can ask you, I know what the output is when I put x in. Now what is my output when I put 1 in? Now that just means everywhere you have x, you will substitute 1. So this is just equal to 1 squared minus 2 times 1 plus 1. So this you can do on your calculator. It's very simple. It's 1 minus 2, which is minus 1, plus 1, which is 0. Okay, so when I have an input of 0, my output, when I have an input of 1, my output is 0. That's what it means. Then your input doesn't always have to be a number like 1 here. You can have another variable as your input. So I could put a into my function and say what will come out. The machine doesn't change because of the input that you put in. So like a microwave, it doesn't change because now you've put a liquid. compared to when you put a solid into the microwave. It does exactly the same thing. So what it does to x, it'll also do to a. So this is just equal to a squared minus 2a plus 1. Okay, then you could also put in longer expressions, not just single variables. So you could have f of x plus h. Okay, so you can do that, and it does exactly the same thing regardless of whatever it is you put in. So this is x plus h squared minus 2 times x plus h plus 1. And then we simplify this one. Okay, for the first part over here, you can use your binomial theorem. This is x squared plus 2xh plus h squared minus 2x minus 2h plus 1. Okay, the best we can do is just rearranging some of the terms, but there's nothing that can cancel because there are no like terms. So that is it in its simplest form. And with functions, you can even put another function into the function. Okay, that is what we call composition of functions. So just for your interest, this is a composition of functions where you have f of x and the input of f of x is g of x, but we're not going to deal with that. But it works in exactly the same way, in that whatever my function is, let's say I have, instead of f of g of x, I say f of x. That means my input is the function f of x, and that means I will be doing this. Okay, and then I work this out in the same way. This will be equal to x squared minus 2x plus 1 squared minus 2x squared minus 2x plus 1, and then plus 1, like that. And then you can simplify it. Yeah, you know how to do that. Okay, so with functions, your input is not always restricted, that it must be a number. It can be another variable, it can be an expression, or it can even be another function. Okay. Now, just for interest sake, our inputs, this is called the domain. And then our output, this is the range. Now your domain is what you're allowed to put into the machine. So that means if you put that thing in, you will get something out. So like you know, with your microwave, no metals are allowed in the microwave, or so I've heard. So your domain will include anything except metals. And then your output, those that's things that you do get out, whether it's warmed food or whatever it is. Okay, so your output is the range. Let's look at some more examples of functions. Let's say we have y is equal to 1 over x plus x. And then we have to work out what y of 1 over x is equal to. Okay, so here our input is an expression 1 over x. So I do the same thing. Everywhere I have x, I'm going to replace that with 1 over x. So I have y is equal to 1 over x plus 1 over x, and this is just x plus 1 over x, which is just the same as what we started with. Okay, so you can rewrite this as 1 over x plus x. Okay, then let's do one more with the same question. Say what is y of minus x squared? Okay, so when you do that, you have 1 over negative x squared plus negative x squared. So this is negative 1 over x squared minus x squared, and that's it. So this is just simple substitution. There isn't anything too difficult to do for this first part. So we just need to understand what is a function, because when we're differentiating, we will be differentiating functions. Okay, so do we have any questions, comments? Are you guys ready for the test? Okay, yes, this means you guys are ready for the test. Then that's good. Then I will see you guys for tomorrow. But the test will be on e-learning at 6 today. All the instructions about how to submit and all of that will be there on e-learning. So please make sure you follow the instructions. Okay, have a good day.